Hello everyone. Today I am going to discuss about RSA algorithm in cryptography. Okay. So what is RSA algorithm? Okay. So why the people are naming it as the RSA? Okay. So RSA RSA is all about the author's name. Okay. So three inventors' name. Okay. So the first name is Rivest, and the second name is Shamir, and the third one is Adleman. Okay, so these three scientists are invented by this algorithm. Okay, so why the people, this kind of scientists, these three scientists are invented this algorithm means. So in order to transfer some confidential information from sender to receiver side, so we need some efficient algorithm technique like RSA algorithm to protect some to protect the confidential information. Okay. So these are in my previous session. I explained the Diffie-Hellman cryptographic algorithm. Okay. So the Diffie-Hellman cryptographic algorithms are it's a symmetric cryptographic algorithm. But whereas the RSA algorithm is an asymmetric public asymmetric encryption algorithm. Okay. So now let's see what is symmetric and asymmetric. So symmetric it is all about. So we are using the same key on the both sides. For example, sender side as well as the receiver side, we are using the same keys. But whereas in the public key cryptography or asymmetric key encryption technique, we are using different keys. Okay. For example, private key and public key. Okay. So whenever we want to encrypt the message, so we need to use public key. But we need to again we need to decrypt the message on the same message. So we have to use the private key. Okay. So this is the mechanism for asymmetric key encryption algorithm. Okay. So the same mechanism is implemented into that RSA algorithm, cryptographic algorithm. Okay. So the thing is, this is asymmetric key encryption algorithm. Okay. So this is asymmetric key encryption algorithm. So this is there are three scientists are involved. Okay. So that is Rivest, Shamir, Rivest, Shamir, Rivest, Shamir, and Adleman algorithm. Okay. So Rivest, Shamir, and Adleman algorithms. Okay. So this is the shortest acronym for that RSA algorithm. Okay. So this RSA algorithm is the asymmetric key encryption algorithm. Okay. That is asymmetric key encryption algorithm. Asymmetric key encryption algorithm. Okay. So there are two keys are used. Okay, so different key we use for encryption as well as decryption. Okay, so that such keys we will call it as private key as well as the public key. Okay, so this is the basic information about that RSA algorithm. Okay, so why we are using these kind of algorithms? So in order to protect confidential information. So protect confidential information. Okay, so this is the reason for we are using that cryptographic algorithm, that RSA cryptographic algorithm. Okay. Now let's see how does this RSA algorithm works. Okay, so with a numerical example, we will see how does this RSA algorithm works. Okay, now, okay, so now let's see the step one. Okay, now let's see the step one. Okay, now let's see the step. So what is the step one? So we need to consider two large prime numbers. We need to consider two large prime numbers. Okay, so consider two large prime numbers. Okay, so two large prime numbers such as P and Q, such as P and Q. Okay. For example, let us take P is equal to 3. Okay, so P is equal to 3 and Q is equal to 5. Okay, so 3 and 5. So these numbers are prime numbers. So what is prime number? The number itself the prime numbers are we will call it as it can be divided itself or by 1. Okay, so that this kind of numbers we will call it as prime numbers. Okay, so this is the first step. We need to consider two large prime numbers. Now let's see step 2. So what is the step 2? So we need to find out the n values. Okay, so the n values. Okay, so what is the n values? For example, we need to find out the n values now. So n equal to p into q. Okay, so n equal to p into q. So here n equal to p into q means so 3 into 5, so total 50. Okay, so n into q means so the n value is 50. Okay, so after finding, okay, so after finding these n values, we need to find out the pi of n values. So what is pi of n? Pi of n, we will call it as Euler quotient function. Euler quotient function. Okay, so here the RSA algorithm uses p minus 1 into q minus 1. Okay, so p minus 1 equal to q minus 1. So already we know the p values. What is the p values? Is 3. So 3 minus 1 and the q values 5 minus. So here, so 2 into 4. Okay, so here 2 into 4. So what is the value we will get? Like you will get 2 into 4. So the pi of n values is 8. So this is the pi of n values. Okay. So now let's see why these Euler quotient functions is always subtracted with 1. Okay, so there are some reasons are there. Okay, let's see the reason. Okay, so this is the first 2 steps. Step 1 is we need to take two large prime numbers. That numbers we assume that p and q. So okay, so we took p equal to 3 and q equal to 5. So after choosing these two, for better understanding, actually we have chosen only small prime numbers. Okay, if you are doing calculation, you must choose some large prime numbers. So here we chosen p equal to 3 and q equal to 5, and step 2 n equal to p into q. Okay, so for multiplying these two large prime numbers, and finally we will get n equal to 15. Okay, so after finding out if the n equal to 15, then we need to find out the quotient, Euler's quotient function. Okay, so the pi of n we will call it as Euler's quotient function equal to p minus 1 into q minus 1. So p and q values already we know. So 2 into 2, 8. So the now pi of n value is 8. Okay. Now what we will do? We need to understand why they are always subtracting minus 1. Okay. So let's see the reason. Okay. Let's see the reason. Suppose, let us assume that, suppose I want to find out the pi of, okay, so I want to find out the pi of n values. So pi of n values means, suppose, let us take pi of 5, okay. So I want to find out the quotient, pi of quotient value of 5. What is the quotient value of 5? Okay, so for example, we are taking 1, 2, 3, 4, and 5. Okay. Now we need to find out the dividing factor of 5. So what is the factor of 5? Only 5. Okay. So only 5. So we need to remove the fifth. We need to remove the fifth one. So what are the remaining values? 1 is there, and 2 is there, 3 is there, and 4 is there. Okay. So the quotient of pi of 5 is, it is always 4. Okay. So which means if you are taking 7, so the pi of 7 equal to 6, pi of 3 is equal to 2. Okay. So that's why we are always subtracting the p prime numbers as well as prime numbers p and q. Okay. So in order to find out the Euler's quotient function, we are always subtracting -1 with that prime numbers. Okay. So this is the reason. Okay. Now let's see the third steps. Okay, so once we find out the pi of it, so we need to find out the public key values. Okay, we find out the public key values. Okay, so already we know that p value is okay. So p value is p value for 3, okay, and the q value for 5, and the n values is 15, and pi of n values is 8. Okay, so these values already be used. So from that value, we need to find out the public key values. Okay, so for now let us consider E as the public key. Okay, so consider E, okay, so such that we need to find out the public key. So here E represent public key. Okay, so how do you calculate? How to find out the public key? So GCD of E comma pi of n is equal to, okay. So in order to find out the public key values, so we must use the greatest common division formulas. Okay, so now GCD of E comma we need to find out pi of n value we know, so E comma 8, which is equal to 1. Okay, so greatest common division. Okay, so now suppose if we are taking 3, okay, suppose how many prime numbers are there? 3 it may be suited, 5 maybe it be suited, and 7 it may be suited. Okay, so now let us take 3, so the condition is satisfied. Okay, so for example, let us see, so now suppose if we are applying, okay, so suppose if we are applying something like GCD of 3 comma 8, it is equal to 1. So E value is 3. Now let's see what will happen. Okay, so for example, if we are taking 3 comma 8, so what will happen? In order to find out the greatest common divisor, so 188, so there is no more possibilities, so we will take 3. Okay, so this is the way we can find out the public key. Okay, so now we know that E value also. So what is the E value? Is 3. Okay, so now this is the step 3. Okay, this is step 3. So this is step 3. Okay, so nothing is there. We need to consider E as public key. So whenever E is public key, it must be satisfied this condition. Okay, so it's GCD of E comma pi of n equal to 1. So GCD means greatest common division. Okay, so we must be find out that public key values, and through that Euler's quotient function. So E comma 8 equal to 1. So whenever we are multiplying, so this E number we don't know. Okay, so that E number, it must be a prime number. Whenever we are choosing some number, that number it must be a prime number. So we are taking that prime number. Whenever we are find out the greatest common divisor, the result it must be a 1. Okay, so here what will happen? So if we are taking that 3, so the common division is 1. Okay, so 3 comma 8, so it will multiply with only 1, so 3, so only 1. Okay, so remaining is 3, so there is no more possibility, so we will stop it. So 3 is the public. Okay, so this is the way we can find out the public. Okay. Now let's see. Let's see the step code. Now let's see the step code. So how do you find out the step code? Okay. Now we need to find out the step code. Okay. So now we know the E values, but we need to find out the private key values. Okay. So in order to find out the private key, let us assume that D is the private. D is the private. Okay. So D is the private key now. So we need to one formula is there. From that formula we have to find out the private. So D cross E or phi of n is equal to 1. Okay. So this is the formula for find out the private. Okay. So now what we will do? D values we need to find out that. So D plus E values already we know that is 3 and mod and phi of n values also we know that is 8. So equal to 1. See, suppose we are taking D values. Okay. So whenever we are multiplying with the D values, the remainder it must be out. Okay, so which is the correct number 3. So suppose we are taking 3 into 3, 9. So 9 mod 8 is always 1. So the condition is satisfied. So by default, D is equal to 3. So this is the prime number of private key values. Okay. So now we know P values, prime number values P and Q, N values, and Euler quotient function values, private key and public. So from that, from these values, we need to perform encryption and decryption. Okay. So now let's see. Let's write the private key. So what is the private key? Okay. So private key. So here private key is D comma N. So D comma N, D already we know that it is 3. What is the N value? It is 50. And what about the public key values? So public key values, it is E comma N. Okay, so what is the E values? It is 3, and again the N value is 50. So now we know the private key and the public key. Okay. So in RSA algorithm, so whenever we are encrypting the message, we are using public key. So with the help of that public key, we are encrypting the message. Okay. So once we are encrypting the message, that message is transferred to receiver side. To the receiver side, they are using their own private key and finally decrypt. Okay. So this is the mechanism for that RSA algorithm. Okay. Now let's see the encryption technique. Okay, so what is the encryption technique? Okay, so what are all the techniques are involved with that particular RSA concept? Now let's see encryption. Okay. So what is the encryption by default? Encryption it is all about the plain text is converted into ciphertext. Okay, so now whenever we are choosing the plain text, okay. So that plain text is encrypted with the help of public key. Okay. So with the help of public key, the plain text is encrypted, and finally we will get the ciphertext. Okay. So here is one condition is there. So the condition is the plain text it must be less than n. Okay. So what is the n value here? 15. So we need to select the plain text. It must be less than 15. Okay. So now let us assume that I am selecting P is 4. Okay, so the plain text is 4. So with the help of these two values, we need to encrypt the plain text. Okay, so what we will do? So now, whenever we are encrypting the plain text, we will get the ciphertext. Okay, so the plain text it must be encrypted. So here encrypted means we need to encrypt it with the help of the public key, the help of the public key. So P power E and mod N. Okay, so and mod N. So now we know the plain text. Okay, so what is the plain text? It is 4. So 4 power 3, E values is 3 and mod N. Okay, so what is 4? 4, we have to multiply 4 3 times. So 4 into 4 into 4. Okay, so 4 into 4 into 4 and mod N. So what is 4 into 4 into 4 and 64. So 4 into 4, 16, 16 into 4, 64 and mod N. So what is, so the N values already we know that. What is the N value here? It is 50. So N value is 50. So N value is here 15. Otherwise for N values here 50. Okay. So mod N values. So N value here is 50. For example, here you will write 50. Okay. So N value is mod 50, and here also it is mod 50. So whenever we are finding the modulus, we will get the remainder is 4. Okay. So here the ciphertext is 4. Okay. So are you clear? So the thing is, whenever we want to encrypt the message, we need public key. So with the help of that public key, we are encrypting the message. Here E represent the public key. So here we consider as P. So the P must be less than N. So P is equal to 4. So 4 power 3 mod N. So we have to multiply 4 power 3 means we have to multiply 4 3 times. So 4 into 4, 4 into 4, so 16 into 4, 64 mod 15. So 4 into 15, 60. So remainder 4. So the ciphertext is 4. Okay. So now what we will do? Encryption process is completed. So we need to decrypt it. Okay. So in RSA algorithm, the decryption it can be done with the help of the private key. Okay. So that is the beauty of RSA algorithm, because this is public key cryptographic algorithm. Public key cryptographic algorithm is all about the senders and receivers side, they are using different keys like private key and public key. So in RSA algorithm, in the sender side, they are using public key, whereas in the receiver side, they are using private key for decrypting the original message. Okay. So this is all about the RSA algorithm technique. Now let's see the decryption process. Okay. So what is decryption process? So already we know the C values. So what is the ciphertext value? Here it is 4. So the ciphertext value is 4. Okay. Now let's see the decryption process. Okay. So here I will write the decryption process. Okay. Suppose here I will write decryption. Okay. So decryption. So decryption process. So here encryption values already we know that. What is the encryption? Encryption already we completed. So we will get ciphertext as 4. Okay. So now we need to find out the decryption. So decryption means we need to retrieve the plain text with the help of receiver side private key. So here plain text, we need to retrieve the plain text from the ciphertext with the help of private key. Okay, so mod here. Okay. So what is the ciphertext here? It is 4. So 4 power B, already we know that private key is 3. So mod N. So 4, we have to multiply 4 3 times. So 4 into 4, 16, 16 into 4, 64. So 64 mod N values already we know that is 15. So 4 into 15, 60. So remainder 4. So we retrieve the original plain text, that is 4. Okay. So this is the way the encryption and the decryption process are executed with the help of the public key crypto system like private key and public key. It is very simple. Both sides they are using different keys. For example, whenever we want to encrypt the plain text, we need to use the public key. But suppose if we want to decrypt the plain text, we need to decrypt the ciphertext, we need to use the private key. So this is why we will call it as asymmetric key crypto systems. So different key was used on the both sides. Okay. So whenever we are using some RSA algorithm, there are advantages also is there and disadvantages also is there. So what is the main advantage? Because it is a public cryptographic system. Okay. So that because we are using different keys, but whereas in difficult algorithms, we used same keys on both sides. It is always vulnerable. Okay. So this RSA algorithm, this is why the RSA algorithms are popular one for many years. Okay, because it is a publicly encrypted algorithm for we are using different keys on both sides. And what are the drawbacks are there? So these kind of algorithms are vulnerable to side channel attack. So what is side channels? For example, the hackers they may steal your private key with the help of the power consumptions and some doing some analysis. Okay, so likewise, there are some side channels are there. The help of the side channels they may steal your private key. Okay, so this is one of the drawback of the RSA algorithm. And what is the second drawback? So here the key size it must be a larger one. Okay, suppose if you are selecting the key as smaller one, so it is already vulnerable to any attack like side channel attack. Okay, so why the key value is very important? So according to that Kirchhoff principle, key size is very important. Okay, suppose even though if your cryptographic system is more complicated, the key must be a very good one. Key size must be a very good one. So here in RSA algorithm, the key size it must be larger than there only it will escape from any attack. Okay, so this is also another drawback. So what is the, why we are considered as a drawback one means whenever the key sizes are increased, by default the computation complexity also increases. So by default, the computational complexity are increasing. What will happen? We need to spend more money. We need more spaces like that. There are so many problems are associated with larger keys. Okay, so this is the way there are so many problems are identified whenever we are using RSA algorithm. Okay, so even though this is the most popular algorithm for using for many people, okay, because it is a public key algorithms. Both sides we are using different keys. So this is all about RSA algorithm in cryptography. Thank you for watching.